Alright, this is a review for 13.3, and the problem says use the given point on the terminal side of an angle in standard position to evaluate the 6 trig functions. Alright, so my point is negative 3, negative 3, 5. So if I go to the left, negative 3, and up 5, I would be right here. When you draw your triangle, you literally trace the direction until you hit the point. So I go to the left 3, up 5. You always connect to the origin, and that origin is always your theta. Okay, so never, theta should not be up here. So theta connects to the origin. So again, trace the point, negative 3, 5. Go to your origin and draw theta in there in your origin. And then I'm going to label these. Not that you can't see what they are, but I can easily find the hypotenuse, right? So a squared plus b squared equals c squared. So that a squared will be negative 3 squared, b squared will be 5 squared, and of course 9 plus 25 is 34, and square root that, so this side will be the square root of 34. Let me just kind of scooch that over here so it doesn't get in my way. Alright, so then I know, oh, and there are no perfect squares in 34, but you know, you should check that, and I certainly think you would. So then I know all the sides of my triangle, so I should be able to evaluate all 6 trig functions. So I'll start with the sine of theta. Sine is opposite over hypotenuse. So from theta, I go opposite over hypotenuse, which would be 5 over root 34, and then I might as well reciprocal this while I'm here, so I know cosecant is the reciprocal of sine. So if I flip that, I'm going to actually write it down here, I get, no, I'm sorry, this is good, square root of 34 over 5. But I need to go back to sine, I'm sorry, because sine is not rationalized. So if I write 5 over the square root of 34, I have to rationalize the denominator. Silly me. So I multiply by square root of 34 of square root of 34, and this is actually 4 root 34. And sorry, I can't erase this now, but that is not a square root. So sine is 5 root 34 over 34. All right, cosine is adjacent over hypotenuse. So from theta, adjacent would be negative 3, and hypotenuse is 34. So if I write that out, I get negative 3. Oh, I'm not going to make this mistake again. I'll write it down here. Adjacent over hypotenuse, and then I need to rationalize. So I'm going to multiply by root 34 over root 34, and I get 3 root 34 over 34. But now with secant, I'm not going to flip this because then I'm going to end up having to rationalize that again. So I'm going to go back to the unrationalized cosine, and I'm just going to flip that, and then I'm good to go. So it's going to be root 34 over negative 3. And last but not least, tangent is adjacent over opposite, or opposite over adjacent, excuse me. So from theta, it's going to be 5 over negative 3. And then cotangent is the reciprocal, so negative 3 over 5. That one's nice because there's no rationalizing. So let me remind you, if you had theta here instead, you'd have your sine and cosine values flipped and your tangent and cotangent values flipped. Obviously very costly, so just make sure theta is always right there in the origin. Alright, finding reference angles, and you may or may not need to draw a picture to help, but I think it's real helpful to visualize personally. So 290 degrees, I'm just going to draw this out, so going counterclockwise, of course, this would be 180, that's 270, and I need to go another 20 degrees. So there's 290. And then remind yourself that a reference angle is an acute angle that connects to the x-axis, so there in red is my reference angle denoted by theta prime. So you have to just figure out how many degrees left. Well, I can definitely see that I went all the way to 290. How much further do I have to go to get to 360? So if I take 360 minus 290, I see my reference angle is 70 degrees. In radians, I have 7 pi over 5. So I'm going to break things into fifths. as best as I can here. So 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5. So there is 7/5, and I'll erase kind of some of these lines here so you can see my terminal side kind of standing out. So again, I know this is 5/5 because that's 1 pi. And so I am going to 7/5, and I need to find the reference angle again, which is an acute angle that connects to the x-axis, so it's going to be this. Well, if I know that this is 5/5, and I need to know the difference then between all the way to 7/5 to 5/5, it's pretty clear that that's going to be 2/5, but I can certainly subtract 5/5, or a pi, right? And I can see that that reference angle, theta prime, is 2/5 pi. Alright, evaluating without using your calculator. So just know that there will be a lot of these on the exam, evaluating trig functions. So I would push pause right now, grab a unit circle, practice filling it out, keep pausing and see if you can answer these before I give it away. So sine of 19 pi over 6. I would first, of course, on my unit circle kind of figure out where that is. So I would put everything in 6 first, again, because that's my denominator. And I'm just going to fill in a couple. So I know 1 pi is 6/6, 2 pi is 12/6, right? So it's obviously going to go all the way around. That's 12/6. And then another 6 would be 18. And then just a smidge more is 19/6 pi. So there's my angle, and of course I recognize that it's in a sixth. Okay, so I know that over here, my angle pi over 6, which is going to be this reference angle, they'll have the same coordinate points except opposite signs, right? This would be all positive. Over here, they're both going to be negative. So what are the coordinates for pi over 6? And if you have your first quadrant memorized, you know that that's a square root of 3 over 2, 1/2. So over here, it's going to be negative square root of 3 over 2 and negative 1/2. And then I want the sine value, and remember, sine is the y coordinate, so that's going to equal negative 1/2. Alright, the next one is secant of 405 degrees. So again, I'm just going to kind of sketch my little unit circle here. You would have yours in front of you. So 360 is all the way around, and another 45 degrees makes 405. So pretty obvious here, because it's in the first quadrant, that this reference angle, which is 45 degrees, right? And I know those coordinates are square root of 2 over 2. Square root of 2 over 2. But I want the secant, which is the reciprocal of cosine. So I'm going to reciprocal my cosine value. And then, unfortunately, I have to rationalize that denominator. And I get 2 root 2 over 2, which simplifies to the square root of 2. Alright, and the last one, tangent of 2/3 pi. So again, kind of visualizing this on your unit circle, or figure out where 2/3 pi is. So 1/3, 2/3, so there's 2/3 pi. And if I know over here that a third pi, have the coordinates of 1/2 and square root of 3 over 2. Then I know over here they're going to have the coordinates of negative 1/2 square root of 3 over 2. So I want the tangent, and tangent is sine divided by cosine, or y over x, right? So I'm going to just do the math here. So y divided by x, which is the same as multiplying by the reciprocal. So reciprocal of 1/2 is 2, and that's the square root of 3. Oops, I'm sorry, I dropped my negative, 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 negative. So negative square root of 3. Alright, a few more, and if you feel like you got this, maybe you don't need to follow along with these last 3 here. Cotangent of negative 7/4 pi. So again, I'll kind of visualize where this is, and it's negative, so I'm going clockwise now. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4 is where I end there. And again, you don't really need all these lines in there. They kind of just get in the way. So there's my angle. Well, I know that the reference angle there is pretty obvious that it's pi-fourths. And actually, I know the point there is the square root of 2 over 2 and the square root of 2 over 2. So cotangent is the reciprocal of tangent. Well, tangent's y over x, so cotangent is x over y. So I'm going to take the x coordinate divided by the y coordinate, and that's easy. That's 1. Cosine of 540, I'm sorry, there should be degrees here. Excuse me. So let's see, 540. Well, I'm going to go around to 360, then I go another 90, and then I go another 90, and that's 540 degrees. So do I know the coordinate point here? I definitely should. That is -1, 0. And cosine is the x value, so that's going to be -1. Piece of cake. And last one, tangent of 90. Oh, another super easy one. 90 degrees is right there, and I know the point there is 0, 1. Tangent is sine divided by cosine, so 1 divided by 0. Oh, I can't divide by 0, so the tangent of 90 happens to be undefined. By the way, if you don't like the unit circle, still not a big fan, well, first of all, bummer for you. But if you don't, please remind yourself you can draw triangles. Now, you can't draw triangles with quadrantal angles, like ones that land right on a quadrant, but this one, the cotangent one, you could figure out its reference angle, which was pi over 4, okay, and then you have to say, well, I know pi over 4 is 45 degrees, so then you'd have to draw your 45, 45, 90, and you know the ratios of those is 1, 1 squared to 2. And then you would have to find the cotangent of, well, cotangent is, tangent is opposite over adjacent, so cotangent is adjacent over opposite. Well, here, pick either 45, obviously, and you want to go adjacent over opposite. So that'd be 1 over 1, and you'd get 1. Now, the things you need to be careful of when you're using right triangle trig is you'll never have negatives when you draw a triangle, but with trigonometry, obviously you can be negative, right, if you're in the quadrants that have negative values. So certainly you can fall back to triangles. Again, I would really stress at this point you're getting comfortable with unit circle.